Ladies and gentlemen, welcome back to PoorConsult's YouTube channel. In this video, we're gonna continue building our dApp that we started in the first part. If you haven't watched it yet, please go on, watch it to understand what's going on in this video. I'll put the link down below in the description. So, just a quick reminder, in the first part, we have started writing the Solidity code for our decentralized application, and we have successfully defined the struct, we have created the array, the function to add the drops, and then we stopped. We deployed it also. So if you remember, now we have this we have the add drop function created, and we have compiled the contract and deployed it. And now for demonstrative purposes, I have prepared some data in here for our drop. Okay, so imagine this is the person, he's going to submit his NFT collection, and according to these variables, okay, that he's required to submit, right in here I have written all these variables. We can add in here and try it and to see if our contract is working properly. You can type in any other variable, it's up to you, just with this format, okay, for the websites and for the price in Ethereum, for your socials. You can just copy with me and fill it in here just to see if this add drop function is working, and then we're gonna query it from the database, from the blockchain actually, to see whether it's operating normally as expected or not. So I'm gonna stop the video here and fill in here all this information and then continue from there. You can do it as well. Okay guys, so here we're back and I've successfully filled in all these fields. Now we click on transact. We can see the confirmation that the data has been added successfully. Now, because this is, we type in the index number and we try to query it back from the blockchain and see if we can see it as or not. Let's query. So this is index 0. The first submission sits at the index 0. We click on drops. And voila, here we see all the data has been retrieved from the blockchain and shown to us just the way we have typed it in, we have submitted it. Okay, all this drop information about the NFT collection, we successfully have requested it, and we can see that everything is there. Of course, the boolean is not approved yet, it's false. We're gonna have to approve it manually, the admin of the project. Well, perfect. Now if we try to add another one, okay, let's say the second person comes and it has not the green apple, let's call it yellow apple, the price to be 0.2, and the rest we can keep unchanged. Okay, just change the price and the name, you can change whatever you want. And then let's transact again. Another confirmation successfully submitted. Now it's on the index 1, right? The second one, it starts from 0, so the second submission is on index 1. We click on there, we click on drops, and let's see, here we go. Yellow apple, you see, and the price is 0.2 ETH. So it's successfully submitted, and that's all we wanted to show in this example. Now we can leave this data here, or we might be using it later, or we can just get rid of it. Actually, we don't need it. I just wanted to show you, so we don't need it. And here I have actually already written a code in here. So you can see, because we don't want to query the data by index, instead we want to query it all at once. Okay, all drops, all submitted applications, we want them to appear at the same time. And let me just delete it and write it once again for you, so as we go like step by step together. So it goes function, and we need the getter function, okay, to get the drops. So let's call it get drops. Okay, the second word starts with capital letter as explained in our tutorials. So this is the function. We make it public view, because it doesn't alter the state of the blockchain, it just reads from the blockchain. Okay, and then returns. What are we returning? So we are returning basically the drops array that we have. Okay, all the drops that contains in our list, right, that has been submitted. We go memory, it's coming from memory, and we wanted to return our drops list, right here, this one, this drops list. Okay, it's as a type of array. Okay, cool. So then now if we can try to compile, we see that it's gonna get compiled. Returns drops. What it says, what error we have in here. Let's see. Public view drops array. I found the error. If you are attentive, you will see that it's not drops, it's drop array, right? So here we had a mistake, not drops, it's drop. And then we try to compile it over again. We see, okay, now it shows no mistakes, so it's compiled successfully. Just make sure these small typos, the smallest mistakes can, but the good thing is that it always shows you what's wrong in here in remix. Okay, so you can find the mistake easily. So now we have this getter function. What else we need? Now let's do the following. Let's suppose people have submitted their drops, but they want to change it. Okay, maybe they made some mistake for the price or for something else, so they want to update their drop. We need to create a function so as they'll be able to do so. And to do it, let's copy this. Okay, we copy it all right, we copy this add drop function, we come in here and below it, let's paste it there. And now what we do, first of all, it's not add drop, we change it to update drop. We come in here and probably we need to update, so we need once we are updating it, so we need to specify which drop, okay, which submission is being updated. So let's give it the unsigned integer 256. Let's specify the index. Okay, they need to specify the index of the submission they are going to change. And after it, what we do, let's take it out, cut it out, this drop. Okay, we cut this out, we cut it out. Okay, and now it's not push. Okay, so we're not pushing anything, we're coming to our drops and we are specifying the index. Okay, the exact index, which in our case equals our drop. Okay, so here we are just saying that from this drops list, okay, under this exact ID, under this exact index, we are changing these variables there. So that's all required for this update function. Now if we compile it, we see there is one mistake in here. We haven't, we have to finish it with this semicolon. Now compile again. Another mistake. Where is the mistake coming from? It's no mistake. It says the stack 2 deep when compiling inline assembly. Okay, because the code is, you see, it's too many memories, and I mean, just don't pay attention to this part for now, because the code is redundant, so it shows us that we need to change it. Okay, it's difficult for Solidity to read the code, and we'll change it obviously, as I have mentioned in the beginning of this video, of this tutorial. I mean, in the last part, we just have made it this way to make it look more of a self-explanatory, but later on we'll change it. As for now, the update function has successfully been created. Okay, and now we continue it. So we have to create an approve function, so as the manager, the admin of the website, can approve the drops submitted by the users. To do that, let me type in the function, and then I'll try to explain how it works and why we write it that way. So we call it approve drop. Okay, a function. We specify the unsigned integer 256. Then what drop are we updating? So we need to specify the index of the exact submission of the exact drop. It's a public function. And now let's see. So what we do, we type in the type of drop. Okay, storage. And the reason we write in here storage instead of memory is because memory is changing it doesn't change the permanent state of the blockchain. Okay, and we don't want temporarily, so we want to update it in the storage, so as we change the state of the blockchain. So drop storage, and we're we call it a drop, okay, the exact drop. It's of a type this drop with a cap. It's this drop. It's of a type drop, okay, that we have specified in here. All right, so this drop, the exact drop, it equals the name of our list, which is drops, okay, and that was specified. Where is the list? Here, okay, drops. So it equals drops, and we need to find in this list the exact drop, okay, so under this exact index that we are trying to approve. So hope it makes sense, right? This new variable, call it a drop, and of a type drop. From this drops list, the exact index we are going to change, and then simply we say this drop dot approved, let it equal true. Okay, so this is the approved drop function, and I hope you understand here what's going on, right? We're deriving this new variable and make it approved, okay, make the state of it true. So that's right. And now what we else need to do, we don't want everyone to be able to update the other person's drop, okay? We want you personally, if you have submitted your drop and want to make some changes, so you can make the changes, but you can't change someone else's submission. So that's why we need to create a mapping for the owner and the ID relationship. And to do it, let's come in here in the beginning, right after this drop array, let's create a mapping. So let's type in here mapping, okay, uint 256, and this go to addresses, make it public, and let's call it let's call it users, okay, all right, in plural form, users. So that's it, that's our mapping. And now we want to create an extra variable and assign the index or the ID to the address, okay? We want to, using this mapping that we're gonna use, but we need to create a separate variable and assign a certain index or ID, whatever we call it, to the exact address, okay? So as we know that this exact address is responsible for changing that exact drop under that exact address, okay? So I hope it makes sense. And to do it, what we do, we come in here, so this add drop function, so after it, right in here, let's type in uint 256. So let's give it the ID of a type, it's unsigned integer 256, and the ID equals drops dot length, all right, the length of the drops -1. So as we have our exact ID, and we said users, okay, under that ID is equal to msg.sender, and the msg.sender is the one who has submitted this application, this submission, this drop, okay? So this creates an ID and assigns this ID to the address that has submitted this drop. After it's done, now we need to do the following. We come here in this update drop, and we want again to make sure the target of doing so was that the person who has submitted this drop, only he will be able to update its drop, okay, that he has submitted. So we come here, and under this public we add the following. Let me edit and explain to you. We go require msg.sender, it should equal to users, okay, and then we go the index, okay, of the user, the index. All right, so what happening here is that this user.index will return us the ID, and if this ID is the same as the ID that was of the person that submitted this drop, only then it will be able to update state of this drop. Okay, they update the drop. If someone else tries, if this ID, the user's index, doesn't match the ID, all right, that was that corresponds to the address of a person who has submitted this drop, then he won't be able to change it. And we can also add a message here. We can say like, you are not the owner, let's say, of this drop. Okay, something like that, or the wrong address, you can write it here, all right, because this is not coming from the address that has submitted this drop at first place. All right, someone else tries to change another one's drop, and we say that no, well, you can't do so. All right, what do we do next? Next we need to define an owner. Okay, who's the owner? And to do so, who is the owner, I mean, of this project, of this contract, the admin of the website, right? So the owner isn't defined yet, so we need definitely to define an owner. So get on top of here, okay, before this struct, let's type in here, let's give a new variable, I mean, let's define the owner, right? So it's of a type address, because by saying owner we mean the wallet address that is deploying this contract. Okay, so address public owner. Now the owner is defined. Next we need to say, so after all, who is the owner? So let's come in here and somewhere, let's do it after our mapping. Let's write the constructor function, and you remember the constructor functions are those functions that are executed at first, okay, in the beginning, all right, before everything else. The constructor function is being executed. So this you can learn from our Solidity tutorials. So it goes constructor, and starting from version 6, if I'm not mistaken, on Ethereum, we don't need to specify public in here, right? Just typing in constructor is enough. And there we need to say that the message.sender, which is the wallet address that is deploying this contract, let it be equal to owner. Okay, so the owner that we defined here is the one who deploys this contract. So we have defined the owner. Now what else we need? We need a modifier. Okay, so what is a modifier? Modifier is something that when added into the function tells the machine to go on and execute the code written in the function only when this modifier condition is true, is met. Okay, so you'll understand now. Let's type in here modifier. Let's call it only owner. All right, only owner modifier. We open it up and say we require, what do we require? We require the msg.sender to be the owner, right? To be the owner. If so, the modifier, which is called only owner, it has a requiring condition which says that the message.sender, whoever tries to accomplish something, it must be the owner. Okay, so if it's not the owner, and the owner is the wallet address that has deployed this contract, because we have set it to be that way in our constructor function. So the require only modifier, the modifier only owner requires the message.sender to be the owner. Otherwise, we can add a message saying that you are not the owner. Okay, let it be that way. And here we need semicolon and underscore semicolon, which says that if this condition is true, then go on and render the rest of the code. Okay, so if this condition isn't met, then you stop and you don't execute the code. Otherwise, go on and render it. So this sign means that. And now we can take this only owner. Okay, we can copy it. And we can go down, and in here, when we're the admin, the creator of the website, when he was trying to approve the certain drops, we want to make sure that every user, whoever wants, cannot do so, but we need this only owner modifier. Now we add in here, so the code comes and then he meets the only owner, and then he checks if this address belongs to the owner, which means the one that has deployed this contract. Okay, if it's true, based on the modifier, then the message.sender, if this owner, then he can approve the contract, approve the drop. Otherwise, he won't be able to do it, and it will give him an error. Now we are basically done. However, we need to make some changes because you can see here the compiler is complaining, and it's doing so because we got a little bit of too many variables, all these string type of variables that we have defined, and we did so in the beginning so as it got to let it be a little bit more self-explanatory and easier for you to understand what we were doing. But as we have mentioned in the beginning, we need to introduce this struct type to make our code look nicer and easier, and make the Solidity to be able to handle it. All right, otherwise it can't. So that's why it's complaining. And now let's get back to this struct type. Let's apply some changes. So what we need to do is, first of all, we need to get rid of all these variables from here. We delete them, and let's go back. So here we need to introduce again this struct type. Okay, so the drop, and then we add the word memory and the variable underscore drop. Okay, so this is it. We good. And now from here public, we also need to delete all this stuff. We don't need it here. Actually, right from here, this drop part, we don't need it. Let's get rid of it. And now we drop push, and we need to push to the list of all the drops, this certain drop from here, right? So we push that drop into this drops list. Remember, we have defined this drops list here, right, into this drop array. Okay, so we push it there, and we are fine. No, we need also one more thing. We need also to up in the approvement part, right? So we need to go drop dot approved, and this equals false. All right, so as later on the owner of this contract, the deployer, will be able to approve it. Okay, by default it's set to false. Perfect. So now we can make it look a bit tighter. All right, beautiful. And so we have here this way, okay, the struct, new variable drop, the approved false, and then we push this underscore drop into our drops array. So this is the first thing we have to do. And the second thing we need to change, after changing this add drop, we need to change also this update drop function, right? Because initially these two functions were using this struct, and then we made those changes. So since we have updated this add drop function, now we need to change this update function as well. So with the same way, let's get rid of these variables from here. And then so it's unsigned integer 256 index, and then again type drop memory, then we have our drop underscore drop. Okay, this is good. Let us make it look nicer. All right, and then in here we have this require statement. We don't touch it. We come here, we take this drop, we delete it. All right, we don't need it, and we say our drops square brackets underscore index equals our drop. Also, finally we need here to add again this underscore drop dot approved equals false. All right, so it's false. And now if we compile, okay, we have a mistake. What mistake we have here? expected but got identifier. Somewhere we forgot. Oh, is it in here? Yeah, we forgot the semicolon. Let's compile again. Another mistake. What it says again, somewhere we forgot the semicolon. It's here. One more time. What it says now. But again, where did we forget? Oh, damn it. Need to remember, guys. We need to remember these everywhere, every time. Semicolon. Try it again. Where now? What it says? Not found, not unique identifier. What identifier is not unique? Mapping addresses, public users. Let me see what mistake we have made here. Users index. Identify not found or not unique. So, alright guys, looks like I found the mistake. You probably have already seen it. It's not addresses, okay, instead it's address. And we have another mistake here. It's not msg.sender equals owner. Instead we need to write down owner, okay, equals msg.sender. Alright, it's important this way. And now if we compile, we'll see that it's finally successfully compiled. It's alright guys, when you type a code, I mean, you can sometimes be in a hurry or just forget those semicolons in Solidity, whereas like in JavaScript you don't have to finish it with semicolons every time. Here you have, and you might see some mistakes, but the good thing is that the compiler, this Solidity, this remix, it helps us, it gives us those hints so as we can easily find the mistakes in the code. And here while writing I'm showing you how to do it and how to find the code, how to find the mistakes. Guys, looks like finally we are through and we are done with writing our contract. It looks nice and seems like we didn't forget anything. The smart contract for our project that we are creating now is looking fine and ready to be deployed. So now I'll show you how you're going to deploy it on the blockchain, because so far that we have been deploying it, we are using the JavaScript virtual machine. Here you see this London, Berlin, these are all virtual machines, these are remix VMs, okay, but now we need to deploy it on the actual blockchain, so as later on we can build the front end and make our application fully functional. So how we do it? First of all, we can deploy it on different blockchains. All right, so we have here, you see, Rinkeby testnet, which is a testnet for Ethereum. All right, and we have like Polygon, we have Harmony, we have Avalanche, we have Binance Smart Chain. All these blockchains are Ethereum virtual machine compatible, meaning that you can deploy your smart contract on any of them. I'm gonna choose the Rinkeby test network. If you don't have, I mean, you should have in your MetaMask Rinkeby test network, but if you don't know how to get this test ETH, you can check our video. We have a dedicated video for it. I'll post the link down below in the description of this video. You can refer to it later on and get some test Ethereum for you for this Rinkeby test network. Okay, so once you have the test ETH, or if you want to go crazy and try with the mainnet, just choose Ethereum mainnet or smart chain mainnet and do it there. But if you're gonna go step by step with me, and you should want to do it, so as later on we can need to go back to the contract and test a lot of things, you don't want to spend the real money, so just choose the Rinkeby and add some test ETH there. Once it's done, what we do, once it's done, we come in here. So okay, it's compiled. Let's just check it again. All right, the contract is compiled. Then for deployment, we are choosing now injected provider MetaMask. All right, click on it. It automatically indicates the Rinkeby 4 network, which stands for this Rinkeby test network. We can see that the account is I think we are on the wrong account. We need to connect it, so let's click on connect. Okay, now we are connected, and you see this 0x3f9. Okay, now we are on the right network. And then we come in here, we checking the contract once again. Seems like fine to me, we didn't miss anything, so we click on deploy. All right, and now you see, because we are posting it, we are deploying it on the testnet, or even if it was on the mainnet, it doesn't momentarily like instantly show as it was with the virtual environment of JavaScript. However, here the MetaMask window pops up, suggested gas fee, let's choose aggressive one so as it gets deployed fast. Anyway, just test network, right? Test it, and then we click on confirm. Okay, so the transaction is pending. All right, so it's being deployed on the testnet blockchain, all right, Rinkeby, and we got the confirmation that it's been successfully deployed. We can even check it this way. You can go to MetaMask. We can come here. Okay, so come here, click on this, and don't scroll down. Instead, here, view on the block explorer. Okay, so we click on it, and this Rinkeby etherscan.io website, which is like Etherscan but for the testnet, okay, for Rinkeby testnet, where we check the transactions. And then here we see that it has been deployed, and this is the contract address. So this is the address that we need. You click on it, and now here we come. 1 minute ago, from this address, which is our MetaMask wallet address that we have been using for deploying our contract, all right, we have created this contract a minute ago. Okay, it's ready. The contract itself doesn't have any Ethereum on it. All right, the balance of the contract is 0, and the contract is ready. And if we come here, we'll see that the contract isn't verified yet. So first of all, let me tell you that this is the contract that we're gonna use, and we'll interact with it lots of times while building the continuation of our project. Okay, the fully operatable decentralized application. However, we need first of all to verify our contract, and even though there are many ways to do so, which you will learn later on when deploying the contracts, not with Remix, but instead you will try Hardhat or Truffle, these more professional solutions. But I found it easier for you to teach this beginning tutorial in Remix, and so as now I'm gonna show you how you can get your contract verified in Remix as well. So we need the verification of the contract. You can't go without it. So how to do it? Click on verify and publish as the website suggests, and then we scroll down. We choose the, what is it? It's a Solidity single file. Okay, and then scroll down. Let's see which compiler did we use to compile it. 0.0. okay, for you it might be 0.8 and 7. okay, whatever you see here. So come here and choose that exact version, okay, of Solidity compiler. Oops, I have chosen it, and then it says what is that? MIT license, right? It was an MIT license. Double check. Yes, MIT license, and then continue. So here we come. It asks a question, it's optimization, yes or no. It wasn't optimized. However, if you are deploying your contract, you could have chosen to optimize it. It was in here, you see. It was not here when we were compiling. Here, advanced configurations, there is an optimization enabling choice. You can click on it. It doesn't make any much changes. It just decreases the transaction fee when deploying the contract. Okay, so if you are working on Ethereum, it might make a difference for you. For other networks, especially on the testnet, it doesn't make any difference. So here we need to enter Solidity contract code below. Okay, it's written. So come here and copy it all, bring it back, paste it in there. Okay, so far so good. Scroll down, we have constructor arguments ABI encoded. So in our case, guys, because we don't have any constructor arguments here, you see the constructor function, it doesn't contain any arguments, so we are going to leave this page blank. All right, and we don't have anything more to do. We just click I'm not a robot, verify and publish. However, I've heard that many people are getting stuck here. They don't know where to get this constructor arguments ABI in case they had the constructor arguments. So I'll show you how to do it, okay? Because in your smart contract that you will be creating one day, it might contain, and the contract usually contain those arguments in the constructor, so you need to know how to find it. So let's get back and make some changes in our contract to demonstrate you how to get it. Let's say we have an argument here which is of a type string. If it's string, then memory, and let's say name, okay? Once deploying the contract, we specify a name. And so we need to have this variable in here. So let's go string name. All right, we scroll down. Where is the constructor? Okay, so it's not name, it's underscore name, right? Underscore name, and in here we can type name equals underscore name. Looking fine for me. So this, we added the constructor argument name. Okay, the variable is there. Perfect. Now if we come in here, okay, and we don't need advanced configuration. Okay, so we need to compile it first. Oops, it shows an error. Oh, you see semicolon again, forgot to add it there. Compile. Good, it's now compiled. Now when trying to deploy, you see, unlike the first time when we did, now we have here when deploy we have this string name, because this is a constructor function, so we need to specify its parameters, okay, arguments, I mean in the beginning. So here we need to write down the name, okay, and for the name, let's say, I don't know, Jackson. Okay, Jackson, this is the name we want to specify. We give this argument to the constructor function, and you might have one argument, you might have many arguments. If it's many, then you just have different of them here, you all type in there, and then you see this sign, this copy. Okay, so you just click on copying it. All right, you copy it, and then open your text editor, okay, whatever you use. I use this Visual Studio Code, so open it up, come in there and choose randomly a place and create a new file, give it some name like sample or whatever .txt. okay, create a txt file and paste, click on paste. All right, so you paste it there, and then choose another file, whatever, and then go back to it, click on it, choose another file, go back to it. Okay, so we paste it there, and then we click open another file, and then usually once you go back, you will see it changed into this bunch of numbers, all right, and the letters written there. You scroll down to the final part of it. Okay, so here is what we see. We see the entire code, which contains of random numbers, and it actually hurts my eyes while looking at it now. So random numbers and letters, but when scrolling down at the end, you will see that starting from some point, it starts with these zeros, all right, these trailing zeros. You see, it goes 0, zeros, and then hoops, a number, and then another, some numbers, letters, and then another zeros. So definitely you will see that at the last part of it, okay, starting from some point, and I do think that it starts from here, right from here till the end, we have these trailing zeros, and this is the ABI of our arguments. Okay, so you come in here, you copy this part, okay, you copy it, let's minimize this, and then you'll go to there, like here, and then you will paste it here. Okay, so you will paste it there, and you will then click on verify and publish, and it will go through. I assure you, in the next videos when we'll have this type of smart contract, we'll do it that way. So you understood it, right? I hope it makes sense. But in our case, because our actual smart contract that we have already deployed, now I can't change, right? It's already on the blockchain, on this testnet, Rinkeby testnet. So we don't have an argument, so I'm just gonna click on I'm not a robot and click verify and publish. So let's wait a second. Hopefully it will go through smoothly and fast without issues. Let's see. Alright, successfully generated bytecode ABI for contract. Awesome. Let's click on the contract again, and now you see this nice looking green check mark at our contract. Means that it's been verified. And we can scroll down. We'll see that our contract now accessible to anyone who has whoever has our contract address, this address that you can give to anyone you want. All right, so people can go there and they can see your code. All right, they can verify that there is no malicious code there. I don't know, some for financial applications it's very important to keep it I mean the code, people come and see if they doesn't have any like malicious stuff happening there. So as they check it, everything is fine, the code is there, the ABI, you see, contract ABI, everything is there. And then we can have two options here, you see, the read contract and the write contract. Okay, so these two options are, I mean, we are not going to use it because we are going to create the decentralized applications front part where the users can have the very user-friendly interface and interact with our contract from that front-end page. Okay. However, if sometimes you see a website, I mean the project, the decentralized application, and its website goes down, or the hosting, it has issues, it goes down, you can always interact with the contract if you know the contract's address from this page. You can read the data. All right, here you can read the data, and you can write the data if you have the rights to do so. If you are the owner, you can connect your wallet and you can interact with it. And in our upcoming videos, we'll definitely have to deal with this page and interact with our dApp, with our smart contract, using these two options. So you'll get familiar with it definitely for sure, like in the upcoming future in our videos. So that's all, guys. Now the smart contract is ready and it's been successfully deployed on the blockchain. Starting from the next video, we'll use React.js to create our front part, and most importantly, how to interact with this backend code. We'll somehow connect our contract with the front page, and it's gonna be lots of fun. And hope you enjoyed the video. If you did so, please give it a thumbs up. If not subscribed yet, please do so, not to miss future upcoming videos, the continuation of this series. And that's all for today, guys. Have a nice day, and see you soon. Goodbye.